All right, let's dive into a workflow that is, and I'm not exaggerating, an absolute game changer for building complex systems, especially things like Agentic AI or game engines. It's called Specification-Driven Development, or SDD for short. And it's all about turning those fuzzy design ideas into solid, bulletproof, executable contracts.
You know the feeling, right? We've all been there. You get a design goal like, the AI should feel smart. And you think, what does that even mean? How do you build it? More importantly, how do you prove that you've built it? Well, this is the exact problem SDOD is designed to solve. It forces us to translate those subjective feelings into concrete, verifiable criteria, like making sure that even when our AI is thinking in parallel for speed, the results are always applied in a stable, predictable order.
So how do we actually make that leap from a vague idea to really concrete code? Well, the answer is a super disciplined approach called Specification-Driven Development.
At its heart, SDD is a workflow where your spec, and we're often talking about a simple Markdown file, isn't just some documentation you write at the very end. No, it's the central blueprint. It's what we call a first-class artifact. It literally dictates the tests you're going to write, and those tests then guide every single line of code you implement. The spec becomes the single source of truth for everyone.
You know, a great way to wrap your head around this is with a simple analogy. If you're familiar with test-driven development, or TDD, just think of SDD as TDD with a maintained spec. It takes that core discipline of TDD but elevates it by making the specification the official living test list.
And this is where it gets really interesting. TDD is fantastic, don't get me wrong, but it's really a local workflow. It's about changing a specific piece of code safely. SDD is much broader. It's about the entire system. You're explicitly defining the architecture, how different modules are going to integrate, and you end up creating what we call living documentation that can't go out of date, because it's directly tied to the tests.
All right, let's get practical. How does this actually work day to day? It's a beautifully simple but incredibly powerful loop. Spec, then tests, then code.
So the workflow is this four-step cycle. First, you write or update the spec. You're defining why you're building this thing and how you're going to observe its behavior. Second, you write tests that map one-to-one to every acceptance criterion in that spec. Third, you write just enough code to make those tests pass, and no more. And fourth, and this is absolutely critical, you keep the spec true. If the behavior changes, you update the spec first. This is how you avoid spec debt, which is just as dangerous as technical debt.
Okay, but how do you decide what to specify first? The MDA framework, that's mechanics, dynamics, and aesthetics, is a brilliant way to think about this. You start with the mechanics. What are the absolute rules of the system? Then you move to dynamics. What kinds of behaviors emerge when those rules interact over time? And finally, you tackle aesthetics. How does it all feel? And here, even feel becomes testable through things like performance budgets and observable signals.
Okay, now let's apply this to the ultimate stress test for any development workflow, building complex agentic AI systems. This is where SDD goes from being just a good idea to being absolutely essential. See, the whole nature of agentic AI is that it's often emergent, unpredictable, stochastic, and without discipline, you just get chaos. SDD provides that discipline by forcing you to treat determinism, that is, the ability to get the exact same output from the same input every single time, as a core, testable requirement right from day one.
And this right here, this brilliantly illustrates the point. This is a real acceptance criterion from an AI system spec. It doesn't just say, make the AI fast. It creates a specific testable contract. It says, sure, you can evaluate agents in parallel to get great performance, but you must apply their results in a stable, predictable order. That's how you maintain determinism. That's how you prevent chaos.
And this is exactly how SDD lets us enforce those non-negotiables. You need randomness, but you can't have chaos? Well, you specify a seeded, reproducible random number generator for every single agent. You're worried about weird glitches? You demand stable, repeatable outcomes for all interactions. And that vague feel of an AI? You make it observable by defining specific telemetry tags that your tests can actually measure.
Okay, let's wrap this up with something you can start using immediately. Here is a simple checklist to make sure you're actually putting the spec first in your own work. Before you write a single line of implementation code, just ask yourself these questions. Can a teammate take your spec and write tests from it without having to ask you for clarification? Are your criteria objective, or are they subjective? Can the behavior actually be observed and measured by a test? If the answer to any of these is no, the best thing to do isn't to start coding.
It's to go back and tighten up that spec.
Because ultimately, this is what it all comes down to. The entire goal of specification-driven development is to take those subjective, fuzzy design ideas and convert them into a concrete, reproducible, and testable contract that guides your entire team.
So, I'll leave you with this final thought. Take a look at the feature you're working on right now. Is its design just a vague idea, maybe floating in a document somewhere? Or is it a reproducible contract that you can actually prove is working correctly today and a year from now?